This is the world after Avogadro. I am assuming that you have watched the video Gases and How They Combine. We're now going to go into why we believe in atoms and molecules and how we get our atomic mass scale. It has everything to do with the evidence we've seen. You've just watched a video called Gases and How They Combine. The law of combining volumes, which you saw demonstrated in that video, tells us that when gases are at the same temperature and pressure, and they react, they always react in ratios of small whole numbers, like 1 volume of hydrogen to 1 volume of chlorine, or 1 volume of oxygen to 2 volumes of hydrogen. This suggested to us that the molecules are pairing off, molecule by molecule, 1 to 1 or 2 to 1, and it suggested, as Avogadro saw, that equal volumes of gases contain equal numbers of molecules. This leads to a song that all my students know and you may want to learn yourself. Equal volumes of gases at identical pressures and temps have the same number of molecules, whether basketballs, balloons, or blimps. We know the great Avogadro found a hypothesis none deny. Equal volumes of gases have identical moles, it's no lie. You may want to sing this yourself. I've given you the whole lyrics here for your enjoyment. But let's move on. We introduced just a moment ago the word mole. A mole of anything is simply a number. It's a way to count things. But it's a way to count huge numbers. A mole of atoms is the number of atoms that add up in grams to the atomic mass that you see on the periodic table or on a table of element masses. So for instance, a mole of hydrogen atoms is the number of atoms needed to make 1 gram, because 1 gram is what you see on the chart of atomic masses. A mole of oxygen atoms is the number of atoms needed to make 16 grams. You saw that we got these numbers from the masses that we derived from our density of gas measurements. Now, if Avogadro is right, and he is, we can find the mass of equal volumes of moles, and we can develop tables of molecular masses, working from, as I said a moment ago, working from the relative masses of the gases. Let's look at some ideas about that. This is a slide that we saw on a previous show. The relative mass of carbon dioxide, if we set oxygen at 32, and we'll just say grams per mole, carbon dioxide has a greater density than oxygen, and by doing the calculation, we see that it is 44 grams per mole. Helium 4, oxygen of course 32, hydrogen, the lightest, is 2, air is 30, and methane, natural gas, is 16. Oxygen was our original standard back in the 19th century because it reacts with so very many elements. With oxygen set at 32, hydrogen now has a mass of 2 grams per mole. Carbon dioxide is 44 grams per mole. And if carbon dioxide is CO2, something that has been established by other experiments, since 44, the carbon dioxide, minus 32, the oxygen, is 12, we say that carbon must have a molar mass of 12 grams per mole. And as you can see, that is approximately what we have on our periodic table. Using a similar process, we can get all the atomic masses on the table. A more complete understanding of this, of course, we'll look at in AP Chemistry. To recapitulate, all gases compress, and all gases compress in the same way, even though their densities are vastly different. Kinetic molecular theory tells us that gases are made up of a huge number of moving particles, even in 1 milliliter of gas. They are very, very tiny. They move very, very fast. When they hit the walls of a container, they exert pressure, and it can be a huge pressure. Now we know that different gases at the same temperature will exert the same pressure in a given volume. Now the heavy gas particles are moving more slowly than the light ones, so they can have the same average kinetic energy because the heavier they are, the slower they are. The lighter they are, the faster they are. And finally, once we know with Avogadro, from the law of combining volumes, that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules, we can calculate relative molecular masses, and we can create our periodic table of elements with those masses. This is how we get the periodic table of elements, the masses in that table. And if you'd like, you're welcome to sing along. Equal volumes of gases at identical pressures and temps have the same number of molecules, whether basketballs, balloons, or blimps. We know the great Avogadro found a hypothesis none deny. Equal volumes of gases have identical moles, it's no lie.